This is just corn. Dry, loose, ordinary. Something so common that most people never stop to think about it. But inside this system, it becomes something completely different. Thousands of perfectly shaped feed pellets are produced every single minute. Each one built with precision, consistency, and purpose. What looks simple on the outside hides a process that is far more controlled than most people imagine. What takes months to grow in the field is transformed in seconds inside a factory. And once you see how that transformation actually happens, you stop seeing animal feed as something basic. It begins far from the machines. It begins in the field. Across vast agricultural regions, corn is harvested at a scale that most people never truly witness. Entire landscapes are dedicated to this single purpose, stretching as far as the eye can see. Modern harvesters move through the fields in long, straight lines, cutting through rows without stopping. The process is continuous, efficient, and designed to handle enormous volumes in very little time. From a distance, it looks simple, just a machine moving forward. But up close, everything is calculated. Speed, cutting height, separation, and collection are all controlled with precision. Because this is not just harvesting. This is the first step in a transformation that will change the material completely. The kernels don't stay in the field. They don't wait. They move immediately. From plant to machine, from machine to storage, from storage to transport. Within minutes, the grain is already leaving the field. In large-scale systems like this, time is never neutral. Every delay creates pressure that carries through the entire process. So everything is designed to keep the material moving forward without interruption. The corn is transferred into trucks and begins its journey toward the processing facility. These vehicles carry massive loads across long distances, connecting two very different environments. One is open, exposed, and unpredictable. The other is controlled, measured, and engineered for consistency. By the time the grain arrives, it has already been affected by handling, vibration, and environmental conditions. Even small variations matter when the next stages demand precision. Because what arrives is not ready. Before anything can begin, the grain must be tested. Every load is sampled without exception. Moisture content is measured carefully because excess moisture can compromise storage and processing. Contaminants are checked against strict limits. Even small amounts can affect quality and safety. Nutritional values are also analyzed because the final product depends on knowing exactly what is entering the system. If the grain does not meet the required standard, it does not move forward. There are no shortcuts here. No adjustments made later to compensate, because everything that follows depends on this moment. Once approved, the grain changes status. It is no longer just a harvested crop. It becomes controlled input. But even then, it still isn't ready for processing. Before the transformation can begin, the corn must be cleaned. What comes from the field always carries more than grain. Dust clings to it. Broken pieces travel with it. Small fragments of plant material remain mixed in. In some cases, even stones or metal particles are present. Inside high-speed industrial systems, those materials cannot exist. They would damage equipment, interrupt flow, and compromise the final product. So the grain passes through multiple cleaning stages. Screens separate materials by size, removing larger contaminants. Air systems lift and carry away lighter particles like dust and husk fragments. Magnetic systems extract metal particles that might otherwise pass unnoticed. Each step removes a different type of impurity, and together they create a clean, consistent input ready for processing. What exits this stage is noticeably different, cleaner, more uniform, prepared. Now the real transformation begins. The corn enters the hammer mill, and this is where it starts to lose its identity. Inside the machine, high-speed rotating blades strike each kernel repeatedly, breaking it down into smaller particles. The process happens quickly, but it is carefully controlled. This is not random crushing. The size of the particles is critical. If the material is too coarse, it will not mix properly later. If it is too fine, it may lose the structural properties needed for pellet formation. So the system targets a precise balance, producing a consistent particle size that supports both mixing and binding. At this stage, the corn no longer looks like corn. The kernels disappear completely. What remains is a uniform material that is dry, light, and unrecognizable. It is no longer grain. It is now part of a formulation, but it is still incomplete. Because feed is not just ground corn. Now the system begins building the mixture. Additional ingredients are introduced, each one selected for a specific function. Protein sources support growth and development. Fibers aid digestion and provide structure. Oils increase energy density, making the feed more efficient. Minerals and vitamins are added to complete the nutritional profile. Every ingredient is measured precisely. Every addition is controlled. This is not simple mixing. This is formulation. Each batch is designed for a specific animal, a specific stage of life, and a specific production goal. The difference between formulas is significant. Feed designed for poultry is not the same as feed for cattle. Young animals require different nutrients than mature ones, so the system adjusts constantly, building each batch according to its purpose. Inside industrial mixers, large volumes of material are blended until complete uniformity is achieved. Every particle must carry the same nutritional balance, because inconsistency at this stage affects performance, growth, and health. Once mixing is complete, the material is uniform, balanced, and controlled. But it still cannot hold shape. That changes next. Heat enters the process. Steam is injected into the mixture, raising temperature and adding moisture at the same time. The material begins to change. It softens. It becomes more flexible. Binding properties activate. Starches begin to gelatinize, making the material more adhesive and easier to compress. At this stage, the transformation becomes more noticeable. The mixture is no longer loose and powdery. It becomes cohesive, heavier, and more stable. Everything up to this point has been preparation, because now the process reaches its most important stage, the pellet mill. This is where everything comes together. The conditioned material enters the machine, and pressure builds immediately. Inside, rotating rollers force the material against a steel die filled with small channels. There is only one direction forward: through. As the material is pushed through these channels, pressure increases dramatically. Friction raises the temperature even further. The particles compress tightly. They bond. They lock together into a dense, solid structure. Then the transformation becomes visible. Continuous strands begin to emerge from the machine. Hot, fast, uniform. A blade cuts them to length the moment they exit. And in that exact moment, the pellet exists. Thousands of them, every minute. This is the point where raw material becomes a finished product. It is also the most visually satisfying stage of the entire process. But even now, the process is not complete. The pellets are still hot and contain excess moisture. If they were stored in this condition, they would soften, break, and lose their structure. So they move forward into the cooling system. Air flows through the pellets, removing heat and reducing moisture. The process is controlled and gradual. Cooling too quickly can damage the structure. Cooling too slowly leaves too much moisture behind. So the system maintains a precise balance. As the pellets cool, they harden. Their shape becomes fixed. Their structure stabilizes. Now they can withstand handling and transport. Now they can be stored safely. Now they are ready for the next stage. But the system still checks again. Screening systems remove broken pieces and fine particles. Nothing is wasted. Everything that does not meet the standard is returned to the process. Efficiency is built into every stage. Finally, the pellets move to packaging. Bags are filled, sealed, labeled, and tracked. Each batch is recorded. Each product is traceable. From here, the feed leaves the facility and enters the global supply chain. It moves to farms, feeding systems, and production environments around the world. Animals that will never see a cornfield depend entirely on what happened inside this process. And it all started with something simple: corn. But what leaves this system is something entirely different. A product built through precision, pressure, timing, and control. From raw grain to engineered feed pellets. Through a process designed to run continuously. Because the moment one batch ends, the next one begins.